Okay, I think we should start our conference. On behalf of the organizing committee and students, we congratulate you on the beginning of our annual scientific student conference. It calls significant achievements in science and technology. And today we are going to listen to 10 reports. Our first speaker is Sorokin Mikita, and his topic is convergence as an aspect of globalization. So we may start.
Yeah, okay. Sure. So Nikita, you can share your screen. You can switch on the demonstration of your presentation and please begin.
Can you see my screen right now?
Yeah, almost.
Yes.
And now?
Yeah, everything is okay.
Good morning, everybody. My name is Nikita Sorokin, and I will present my report on the topic convergence as an aspect of globalization. So let's begin. Humankind has been changing during its history, beginning with the ancient philosophy of atomistic ideas through theocentric views to a brand new, rational approach to unraveling the mysterious greatness of nature, science. Having opened the world of information technology, we pushed our progress forth. And now we're standing on the edge of a new era called globalization. Meanwhile, we'll talk about globalization at all and why convergence is considered to be a part of it. Well, globalization is a term used to describe how technology has made the world a more connected and interdependent place. Globalization also includes the economic and social changes that have appeared as a result. Although people have been intentionally working in during the century, the advantage of globalization is outstanding. Convergence is an aspect of globalization. Purpose of it is an integration of technology, physical sciences, and life sciences so that we can form a more viable and complex vision of objective reality just by raising borders between different branches of sciences. In the early 20th century, physicists unlocked the secrets of the atom. When combined with engineering, this knowledge produced some amazing things. Humanity entered this century having unlocked many secrets of still more powerful of life itself, with unprecedented access to the code that makes up our world, which possibilities are endless. So now we will review the most engaging examples of how and why we use convergence nowadays. Some of them you can see right on your screen. Among them are bioengineering, cheminformatics, biochemistry, and bioinformatics. Let's talk about every single part of it, noting only the most interesting parts of convergence. Bioengineering. As you may guess, bioengineering is a conjugation of two of the most powerful tools that humanity has. Engineering and biology being united produce an invention that human could only dream about. Scientists that have chosen that mix of disciplines to work with, engage, researching living systems, and finding the most viable solution to improve our life's experience. The great example of applying it is brain-machine interface. These devices help people's brain communicate with prosthetic limbs, wheelchairs, and other assistive devices to make them move. When they were first developed in 2012, they cost 6 figures, but with continued improvement, costs were coming down and effectiveness continues to improve. So here you can see the applying of bioengineering. And here is an example of neural interface. So about cheminformatics. Cheminformatics refers to use of physical chemistry theory with computer information science techniques, so-called in silico techniques, an application to a range of descriptive and prescriptive problems in the field of chemistry, including its application to biology related to molecular fields. Such in silico techniques used, for example, by pharmaceutical companies and in academic settings to aid and inform the process of drug discovery. Next, we'll talk about biochemistry. Biochemistry is a study of chemical processes within and relating to living organisms. Biochemical processes give rise to complexity of life. Over the last decades of the 20th century, biochemistry has become successful at explaining living processes through these three disciplines. Almost all areas of the life sciences are being uncovered and developed through biochemical methodology and research. Moreover, every day we're facing more and more achievements in this field of study. As you may have heard, the Nobel Prize in Chemistry 2020 was awarded jointly to Emmanuel Champetier and Jennifer Adonda for the development of a method of genome editing. Here you can see their photos. And now we are talking about bioinformatics. An unprecedented wealth of biological data has been generated by the Human Genome Project and sequencing project in other living organisms. The huge demand for analysis and interpretation of this data is being managed by evolving science of bioinformatics. Bioinformatics is defined as the application of the tools of computation and analysis to the capture and interpretation of biological data. It's an interdisciplinary field which harnesses computer sciences, mathematics, physics, and biology. Bioinformatics is essential for management data in modern biology and medicine. Having reviewed lots of advantages of convergence, let us move forward to the final aspect of globalization. Similarly to any other way to recognize nature, convergence has its own philosophy. Its main problems include many ethical and technological questions. Seems like convergence is our new approach to the philosophy of science. Just imagine what new wonders could the future hold if we design new ways to work together. What if we created new fundings, new interdisciplinary institutes, and new strategies for collaboration? Our world's complex problems demand that we foster convergence, and whether we will advance beyond anything we've imagined before. Eventually, convergence gives us a gateway to reach the aim of modern science. Using globalization approaches, we can move forward to developing science and technology until the moment that we will have made up an all-encompassing image of nature. Having this power under control, we will be able to completely transcend the universe to make it a better place to live. Thank you for your attention. That's all. I was pleased to talk to you all.
Okay, thank you, Nikita. Does anybody have any questions? Okay, then let's continue. And next speaker is Monarchuk Anastasia, and her report is about globalization in policy. Okay, you can start, Anastasia.
I'm sorry, I didn't hear you. Did you call Monarchuk Anastasia?
Yes. Maybe
I have bad internet connection. Can I answer in some minutes?
Okay.
Yes, I will write you in the chat, okay?
Okay.
Thank you.
Okay. Then our next presenter is Dubovik Vadim, and he will tell us about robotic integration in our lives.
Yeah, can you hear me? Yeah.
Yes.
Okay. Can you see the presentation?
Yes.
Okay. So, greetings everyone. I'm a student learning at KPI at Faculty of Electronics, and my name is Dubovik Vadim. My topic is robotic integration in our lives, and today I want to say some interesting things about it and to discuss about all pros and cons of modern technologies. Robotic systems make people's life better and easier by integration modern technologies in their everyday lives. At slides, you can see some examples of robots that are already doing it, like vacuum cleaner robots that prepare food, or those that are working at manufacturers. But we'll talk about them a bit later. Properly speaking, some underlying ideas of robotics were established in ancient times. They found the remains of moving statues that were made in the 1st century before Christ. What means this word, robot, robotics? Mostly it was used by Czech writer Karel Čapek for the science fiction play. And it became popular. In general, this word can be used to any automatic device designed for the implementation of various types of mechanical operations, which operates according to a predetermined program. These slides show some ancient variants of robots like Chinese water clock or the water machine for the bird. Nowadays, there is a great amount of these inventions that truly help us because there is so many work that human can't do or can do incorrect, do some mistakes, work in outer space, deep down in the water or underground, manipulations with toxic or radioactive materials and operations that requires high accuracy is often done by machines to preserve human lives. But there is always the other side of the coin. In our days, even the simple work is being replaced by a machine. As example, new type of taxi, the unmanned vehicle, was recently put into operation by Waymo and Yandex. There is no driver in this kind of taxi, so the company don't have to pay. But this causes a new problem, the extinct of professions. Accountants, copywriters, build editors, proof readers, travel agents, loan managers, bank tellers, etc. will simply disappear, and they will have to retrain. Frankly speaking, not everybody capable to do this. The unimaginable amount of time people have spent on their work and the experiences they have acquired will mean nothing. But this is the price we have to pay to use new technologies. And that's all today. Thank you for your attention.
All right. Thank you, Vadim. Does anybody have any questions? Okay, let's continue then. Okay. The next speaker is Dubrovsky Mikhailo. He is going to tell us about prospects of artificial intelligence. Mikhailo, are you here?
Yeah, I'm here.
Okay.
Give me a minute. I will turn on the sharing. Can you see the screen right now?
Yes.
Hello, greetings. My name is Mikhailo Dubrovsky. I'm from Faculty of Electronics, KPI University, and today I will tell you about the prospects of artificial intelligence. What is actually artificial intelligence? Let's discuss first about this. Artificial intelligence is the way of simulating the human mind, like technology that refers to human intelligence simulation. The main goal of this science is achieving high level of efficiency while solving some tasks which are always performed by human. And this task can just vary from chess game playing or to complex routines like automation automatic vehicle driving, including environment analysis, and it's the decision making. So artificial intelligence started its way in the 50s. And first, I want to talk about prerequisites of artificial intelligence. So the first work that actually influenced the subject was a work of two scientists, Walter Pitts, Warren McCulloch. It was first model of neural network and mathematical model of neural network and neuron in particular. Also they created numerous different scientific words dedicated to neuropsychology, which had a major impact on modern theory of cybernetics and the artificial intelligence science. So now let's talk about Alan Turing. He's best known for cracking the algorithm of Enigma machine, but also he written a lot of different scientific works about the artificial intelligence, and he created a model of something that's called the Turing machine. Turing machine is some abstract, I don't know, computational machine, yeah, computational object, I know, that can work in some, which behavior can be described in a mathematical way with the help of mathematical rules and logic. So maybe every one of you heard about such thing like the Turing test. That's the test that can determine whether the person is chatting with or talking to a machine or talking with a human. Like it states that machine acts like it acts in a programmed way, so it can't just remember some things, learn something. And it's the main question, rhetorical question that was asked in this work. Can the machine think? So that's where the story of artificial intelligence started. And the first stage of development of artificial intelligence was golden age of AI. So everything started from chess program, chess playing program was developed by the Herbert A. Simon. He made his scientific researches. He was making his scientific researches in Carnegie Mellon University. And after that, the IBM Corporation started co-working with Marvin Minsky to create the powerful computational to create supercomputers that could just process a lot of data to simulate human mind in some ways. So John McCarthy is best known for his for the creation of LIST programming language that was widely used in mid 16th for programming artificial intelligence models. And Jared J. Sussman, he was a researcher in Massachusetts University, contributed to, did a lot of contributions to the Lisp programming language. So everything started, every ambition can end in some way because of the fact that artificial intelligence was an unpredictable field of science because of the lack of knowledge. Everything ended up with AI winter. That's when the IBM and DAPRA, was a company DAPRA that it still exists, that funds a project, USA project related to some cybernetic researchers. So DAPRA and IBM consult funding to the field. So everything ended up with AI winter. It was caused by lack of knowledge and just low computational power of machines of that time. And of course, when we talk about the neural networks, they must have some space. They must have some data, learn some data. So when they learn, they must store this data somewhere. So that then it was impossible to find such amount of disks with such amount of space like we have today. And AI winter lasted around 10 years. There were several AI winters, but we're gonna cover only one because we're gonna just consider it one big AI winter from the period of from 80s to 90s. So in 90s, thanks to the development of in new computational power, development of the infrastructure and new computational power, there was a possibility for researchers to use new technologies in AI. So there was, so the 90s was a stage when machine learning era started. So what's machine learning? It's the way of, before artificial intelligence acted like just an algorithm without the help of some, not in a dynamic way. So it was just every AI algorithm consisted of some rules and without some dynamics. So the machine learning helps us to make a model that can learn, not just act by algorithm. It can learn and make some predictions or do something using some data it's got from some researcher or the person that's training this model. So approaches, there are several approaches of machine learning. Supervised learning, that's when we actually work with something. Supervised learning refers to algorithms like can you hear me?
Yes.
Yes.
Yeah, just got some internet problem. I'm sorry. Supervised learning was widely used at the start of 21st century, but after that it was replaced by more powerful algorithms of neural networks, because supervised learning is based on using some trees, binary trees, like decision trees, and it's not so efficient way of training the models. So it later was replaced by